are again out. And the vertex, kind of the starting point, is at 5, 4. You always kind of go opposite the sign in there. So obviously the only one that matches that is letter D. You can also do this in Desmos. It's not a complicated problem to do when you've got a graphing tool available. Okay, so we're up to number 5. Great, more graphing. Okay. All right. Okay, so in this problem here, the graph is negative x cubed. That negative really means a lot because the positive x cubed goes like this, but the negative x cubed ends up going the other direction. So that tells you that C and D are out because it's got to look something like this. And then when x is 0, all the terms go away except for that last one. So y is 20. And you can see in graph B, it crosses below the x-axis, and that's how you know right away, okay, it must be letter A. We could, of course, graph this if we needed to. All right, number 6. All right, it says find the asymptotes of the function. So the vertical asymptotes occur when the bottom is equal to 0. So you said x plus 2 equal to 0 or x equals minus 2. And so that gets rid of B and D as possible answers. And then to find the horizontal, you look at the ratio of the leading coefficients 1 and 5. So it's y equals 5 over 1. And therefore, answer C is the best option. All right, let's move to number 7. So actually, this is a lot like one of our first or second lessons. There's almost no calculus up until this point that you need to know to be able to do this. So to solve the equation, you solve this by making the bases of the powers the same. So what I mean by that is we want to make 3, this 3 on the left, we want to make the 81 on the right also be a 3. So 3 to the power of 4 gets you to 81, 8 minus 2x, and then you set the exponents equal to each other. And then you just solve for x. You could even just try the answers. X ends up being 2. Look at something like that. All right, question 8. It says at what rate must $4,000 be compounded annually to equal $6,855 to 2.97 after 7 years? Well, it's interesting we went to 3 decimal places on money. I was working with a 3rd grade student, and like that was the lesson, is like you only go to 2 decimal places with money.
Oh my gosh.
So the equation here is the future value, the thing you're trying to reach, equals the initial value, okay, whatever you put in your deposit, 1 plus, and then because it's compounded annually, you just put the interest rate here to the power of 7. So you're just manipulating this equation to solve for R. So to solve for R, you first divide by that 4,000, and then you undo the power of 7 with the 7th root, and then you end up subtracting 1. So I'm just going to go to a calculator and calculate that for us really quickly here. Let me get mine up. Okay, so let's see here. There's actually an extra 0 there. Oops. All right, so it ends up being 8%, right on the number.
Okay, sorry. We're on question 8. 8%. Gotcha.
Yes. Okay, so let's keep going here. I also have a bunch of windows up, so it's okay. Question 9. 9 here. Open. All right, so the way you solve these logarithmic equations is you have to first combine the logs on the left. So a difference becomes a quotient. So it becomes the log of 4 plus x over x minus 4 equals log 5. And then you set the parts inside the log equal to each other. Okay, and so then you just cross multiply diagonally each side. You get 4 plus x, because 4 plus x times 1 is itself, 5 times x minus 4, and then you're just solving here. 5x minus 20, 4 plus x. So we'll move the x to the right. So that gives us 4x equals 24. Looks like x equals 6. And then normally I would just do a quick check, like, all right, does that even work? Is the log of 10 minus the log of 2, does that equal the log of 5? And 10 divided by 2 is 5. So we can say, yeah, that's going to work out. All right, so let's go to number 10. Another money question. Another money question. Okay, college student invests $10,000 in an account paying 13% per year compounded annually. And how many years will the amount at least quadruple? So we've got $10,000 as our starting amount, 1 plus the interest rate 0.13. And we're trying to figure out the number of years T until this ends up equaling 40,000. Okay, so to solve this, you would use some logarithms. You'd actually first divide both sides by the 10,000. Okay, and then you take the logarithm of this left side. So it ends up being t natural log 1.13 equals 4. And then you take the 4 and divide it by the natural log of 1.13. So you definitely need a calculator for that. And we can do that now. Okay, so I made a mistake here. What mistake did I make? 1.13. Yeah. Okay, so the other way to do it is to actually just try some of these values. I apologize. I don't know why this didn't work. Oh, because I didn't take the log. I didn't take the log of both sides. That's why it didn't work. Okay. So this actually does work. It gives you 11.3 years. It's not a good strategy to check the answers in general. It's the slowest way to go. All right, so you sent a lot more of these. Sorry, oh, okay. So I've done all the ones that were sent by chat.
Okay. I got 11 through 20 via email.
Via email. All right, great. Got it. I see it there. Hopefully you're not, hopefully your stress level has gone down a little bit and you're feeling okay right now.
Slightly. I'm trying to get these to you and then I'll stop sweating.
Okay. Okay. Yeah, the internet will not go down. Okay, so so this one here, they're just what are they doing here? They're actually giving you the answers. I think when we did this, we had to fill in the table. So they're just taking 0.9 and plugging it into this thing on the left here. So
Mhm.
this is just a calculator problem. So I'm going to do the square root of 0.9 plus 1 over 0.9 plus 1, and I'm going to see what it is that we come up with. So I'm actually do it slightly differently. We can redo it. All right, square root of x plus 1 over x plus 1. All right, so that ends up being 0.72548. So with one number, that is the answer. The answer is B. Okay, you're welcome to check. I'll do one more we'll do the next one just to make sure. 0.99, and that is 0.7088.
Okay.
Bad multiple choice. They don't give you much there. All right, next question. Do that. Okay, here we go. All right, so this one, the issue here is when you substitute in -10 in the bottom, you get 0, but you also get it in the top. You end up getting 100 minus 160 plus 60, which ends up being 0. So you end up having to factor the numerator. And what's they kind of hint at this in the problem. One of the factors in the numerator is 10. And you're trying to find two numbers that multiply to 60 but add up to 16. So 10 and 6 work. But I know it's 10 because it's going to cancel out with one in the bottom, one of them in the bottom. So those cancel. And then you take the limit as x approaches -10 of x plus 6. You're literally just putting -10 in for x, and you get -4. All right, so let's look at 13. Any is it clear? Do you need me to go back to just confirm any of these answers at this point?
Can we plan on doing it at the end?
Sure.
Okay.
Okay, it says use the properties limits to decide whether the limit exists. The limit exists finds its value. So because the degree of the numerator is greater than the degree of the denominator, this thing goes to either positive infinity or negative infinity. So you got to look at then the sign of the numbers. They're both positive. I know I covered them up. So what it is like x to the 6x to the 6th goes to infinity, and so does 9x to the 4th. And infinity over infinity does not cancel out. It does go to infinity.
Okay.
And it would only change if the signs were different. Okay, here we go. Got another question here. 14 is about discontinuity. All right, so it says find all points where the function is discontinuous. So that means you would have to like lift your pencil when drawing it. So you can see at -2, there's a hole. At +2, there's a hole. And then at x equals 0, there's a vertical asymptote. So it's those three places, -2, 0, and +2. All right, I'm just going to step away for 30 seconds to grab my coffee. I will be right back.
You're fine.
All right, I am back, and the next problem here is some sort of another discontinuous thing here.
Oh,
right.
sorry. I'm so dumb. Did you give that answer for 15? What was
Yeah,
that?
no, I am now on.
Oh, you're good. You're on 15.
Now we're on 15.
Cool.
We're on 15. Okay, it says find all values x equals a, where the function is discontinuous. So you just have to check the endpoints. Basically, you have to figure out. Well, is that really the right way to do it? Okay, we need to know what's going on here at 0 and 7. Okay, so when x is 0, it's 0 squared minus 7 times 0, and that's 0. Okay, and that's the same as this upper number, so that's fine. When x is 7, it's 7 squared minus 7 times 7, which is also 0. And we want it to be 40. We want it to be 7, so that's a bad place. Okay, so just for clarity, the answer is this. Now, I'm just going to quickly go to Desmos and graph this thing just to confirm what I just mentioned, because I want to make sure that we get this down here. That's not right. Okay. And then yeah, okay. So that is confirmed by the graph.
Okay.
The graph has this sort of shape to it. Does this, and then up here at 7, you can see there's this gap between them. All right, next question. Wrong screen. Okay. Up to 16. Have you sent me a couple more emails?
I have.
Okay. All right, so average rate of change, AROC. AROC, it's a really great formula. F of B minus F of A over B minus A. So A and B are 2 and 8 from the graph there. So F of 8 means it's the square root of 2 times 8, which is the square root of 16, which is 4. F of 2 means the square root of 2 times 2. You're just putting those numbers in for x. Square root of 4, which is 2. So your numerator is 4 minus 2 over 8 minus 2, which is 2 over 6, or 1/3. All right, so I think we're up to 17 now.
Mm-hmm.
New question. This one's got a lot more words to it. We'll see if they're actually meaningful. I'd find the instantaneous rate of change of P with respect to T at T equals 4. So there's a lot of words here, but you're just taking the derivative of this and evaluating it at 4. So I'm going to just do a little bit here to simplify. I'm going to multiply in the 1/3 to both. So it's 1/3 T squared plus 1/3 T. And then we're going to take a derivative. So the derivative is that power rule. You're going to take that 2 and multiply it by the 1/3. So that's 2/3 T. 2 minus 1 is 1, plus the derivative of a number times a variable is just the variable. And then you evaluate it at 4. So you put 4 in for T. So it's 2/3 times 4 plus 1/3. 8/3 plus 1/3 is 9/3, or 3. Looks like it's 3% per day.
Okay.
So it's a really complicated way of saying something. It might have been in the section where you actually had to use the definition of the derivative, which is horrible procedure, but we don't have to do that for this. All right, looks like my screen just glitched a little. All right, there we go. Okay, find the x values where the function does not have a derivative. So that means you're looking for things like a corner, which is what this one is. We talked about a cusp, okay, any sort of breaks in the graph. But it looks like it's just at 0, although the picture's not great. I would say that it looks like a corner.
Mm.
So x equals 0
Okay.
is the only place. All right, so we're up to, is this right? 19?
Yeah.
Okay. Oh, I can't remember that. All right. Okay, so this one says to find the derivative. All right, and this is a pure chain rule problem. Okay, or I'm sorry, not chain rule, power rule problem. So you take the exponent and you multiply it by the coefficient. So it's minus 22x, but then you subtract 1. Minus 2 minus 1 is minus 3. Okay. Plus, take that 3 and multiply it by the 11. So that's 33x. 3 minus 1 is 2. And then the derivative of a constant times a variable is just the variable, or it's just the number. So it looks like, what do we got here? Looks like letter B.
Cool.
All right, here we go. All right, number 20 says find the slope of the tangent line to the graph of the function of the value of x. So this is a complicated way of just saying take the derivative and evaluate it at that number. So you're going to take this exponent, multiply it times the number in front. So it's 9 times 5 halves x 5 halves minus 1 minus 7 times 3 halves x to the 3 halves minus 1. So that becomes 45 over 2 x to the 3 halves minus 21 over 2 x to the 1 half. Okay, and then you just have to take this value of 4 and plug it in both places.
So ugly.
Yeah, it's a lot of fractions. I mean, it's a good question because it's like, you got to remember some stuff from, previous courses. If you've got a calculator, you would just plug it in and not think that much about it. But depending on the class, you may or may not. So 4 to the 3 halves is 8. So this 45 over 2, and then square root of x, or x to the 1 half, is 2. So minus 21 over 2 times 2. So that becomes the 45, that's 4, what is that, 90, 160 minus 21. No, that's not right. 180 minus 21 is 159.
Okay.
Okay, let's go to the next question. Oh, it's another email. All right, here we go. Gotta find that. $21. Got it. Okay, 21. It says find the values of x, if any, where the tangent line to the graph of the function is horizontal. Okay, so they're basically saying take the derivative, just like we've been doing, and set it equal to 0. So the derivative of x cubed here is 3x squared. Go down by 1 there, and then the derivative of a number times a variable is just the number, minus 12. Derivative of a constant is always 0. So like derivative of 2 is 0. So you set that equal to 0, and you solve for x, and you find that 3x squared equals 12. So x squared equals 4 because you're dividing by 3. So x equals plus or minus square root of 4, which is plus or minus 2. And they're both possibilities. really surprised your exam has so many, this practice thing we're doing has so many questions on it. It's like, anyway, okay, sorry, all these thought bubbles. Okay, it says find all points in the graph of the function whose tangent lines. So whenever you see tangent lines means slope, slope means derivative. So we'll get to this parallel stuff in a moment, but you got to be able to take a derivative. 2 times 2 is 4, 4x plus 6, that's your derivative. Now on the right here, if we rewrite the equation by moving the 26x to the right, it's y equals 26x. This has a slope of 26. The slope is the number in front of x, okay? So if they're parallel means they have the same slope. So you set 4x plus 6 equal to 26, and you solve for x. You subtract 6, so 4x equals 20, divide by 4, so x is 5. That's your x value. Now, because it's multiple choice, there's only one of those that has that x value. We don't even have to find the y value.
Okay.
All right, the profit in dollars from the sale of X thousand compact disc players. Wow.
Old.
Yeah. Yeah. I mean, I actually don't have any CDs anymore. I don't know about you.
No. I mean,
Yeah.
I guess a few DVDs, but that,
Yeah.
that's
Yeah.
it.
Well, there's a parallel question that asks about DVD players here.
Huh.
Okay. So they give you this function marginal, and this is a business calculus thing. Marginal means derivative. Marginal means slope. Marginal means take the derivative of this function. So your derivative is 3x squared minus 14x, 2 times 7 is 14, plus 7. And then they want you to evaluate when x is 10. So they want you to find the derivative when x is 10. So 3 times 10 squared minus 14 times 10 plus 7. So that's 300 minus 140 plus 7. And that's $167 per thousand of these devices. Any questions on that? Keep going here.
No, yeah, all good.
All right, all good. So 24 is our next problem here. Let's see here. Okay. Use the product rule to find the derivative, and then they multiply it all out. So we're actually doing it slightly differently. We're just going to multiply everything. Okay, so we're going to do the more traditional approach here. It's 20x cubed minus 20x to the fourth minus 5x cubed plus 5x. And then we're going to take that minus 2 and multiply it by all three. So minus 8x cubed plus 2x squared, which I didn't leave the space for, minus 2. So you combine like terms here, 20x to the fourth minus 13x cubed. We'll put the 2x squared next because it goes before the 5x, and then minus 2. So you're going to take a derivative using the power rule. Again, so that 4 times 20 is 80 x cubed. So that means we're down to B and C. Minus 39x squared. So that means the answer is C, but we'll finish it off here. Plus 4x plus 5 is our derivatives. So what's nice is if they're not grading this, if you're like turning your work in, you'd want to show it with the product rule, but you don't have to because you're just choosing the answer.
Mm-hmm.
All right, use the quotient rule to find the derivatives. The way we talked about doing this is we set u to be the numerator, and then we would find u prime. We would just take the derivative of the numerator, 2x minus 3 in this case. V is x to the 7th minus 2. V prime is 7x to the 6th. Okay. And then the quotient rule says bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay, so you'll notice they're all squared on the bottom. Okay, but in the top, we do have to do this thing. So we have to take v, this x to the 7th minus 2 times u prime 2x minus 3 minus u, which is x squared minus 3x plus 2 times v prime, which is 7x to the 6th. So we need to simplify this. Unfortunately, they don't give you much help here with the answer space. All right, so we're going to foil this one on the left here. 2x to the 7th minus 3, I'm sorry, 2x to the 8th minus 3x to the 7th minus 4x plus 6. And then we're going to multiply each of the ones on the left here by 7x to the 6th, but we're going to negate it. So minus 7x to the 8th plus 21x to the 7th minus 14x to the 6th. Okay, and then that really helps here to narrow down our choice. So the 2 and the minus 7 gives you minus 5x to the 8th. Minus 3x to the 7th plus 21x to the 7th is plus 18x to the 7th. So we're still, if I'm looking at the numerators, two terms in, we're all the same. And then let's see here, minus 14x to the 6th. So that gets us down to A or C, because they both have the 14x to the 6th. But then the minus 4x tells us that, okay, it must be letter C.
Oh, okay. I got it now.
Yeah, this is more of like a standardized test type thing than anything else. You you look at the answers as you go and see which ones, are or are not gonna work. Okay, so thankfully the next question kind of goes back a little bit easier, not super super difficult. All right. So by this point in the course, what the expectation is that what you're supposed to know now is that when you take a derivative of this, the derivative of this ends up being 1 over 2 square root u times u prime. Basically, it's the square root goes to the bottom, the 2 in front, but then you multiply by the derivative of the inside function. So for your problem here, it's 1 over 2 times the square root of 4x plus 2. But then you multiply by the derivative of the inside part here, the inside of 4x plus 2, and that derivative is 4. 4 over 2 cancels to make 2. So 2 over the square root of 4x plus 2. Okay, so this problem wants you to find the derivative of this f of g of x. And there's a formula for this. I mean, it's based on the chain rule, but it's f prime of g of x times g prime of x. We're just gonna assume that that's true for the moment, and then you're evaluating it at 3. So you just rewrite this notation at 3. So it's really 3 pieces. The first thing you do is you find g of 3. G of 3. So there's x equals 3, and g of 3 is 1. So this is now f prime of 1 because g of 3 is really 1. G prime of 3, well, there's 3 again, and we want g prime. Oh, yeah, it's 3. It just so happens to match up with the numbers. F prime of 1, you go to where x is 1, and you go down your list. Oh, that's -2. So this is -2 times 3, which is -6. And thank goodness it's there. Be a tough otherwise. Okay, it says find the derivative of find the derivative of this thing here. So see how all the answers have a 1? So
Mhm.
the derivative of x is 1 because there's really a 1 in front of x. So that doesn't even help. The derivative of e to the u is always itself times the derivative of whatever is in the exponent. So the answer has to have an e to the 7x squared in it. It has to be its original function. So the derivative in your case is e to the 7x squared, excuse me, and then you take a derivative of the exponent. The derivative of 7x squared is 14x. You'll notice though that only one of them has that correct exponent there,
Mhm.
x 7x squared. Okay, let's see here, number 29. All right, the sales in thousands of a new type of product are given by S parentheses of t equals 260 minus 50 e to the minus 0.7 t, where t represents the time in years. Find the rate of change. So rate of change means derivative. Slope, tangent line, they all mean the same thing, derivative, derivative, derivative. Okay, round to the nearest 10th. Okay, so you've got to take the derivative of this function, which is probably the hardest part. But you actually see the thing is, if you actually had your calculator, we would probably use this thing called nderiv to do it for you, especially since the answers are all numerical. But the derivative of this function, the derivative of 260, the constant is 0, minus 50 e to the minus 0.7 t. So whenever you have an exponential function, the derivative is itself times the derivative of the inside part. So times the derivative of this minus 0.7 t, and that's like, it's kind of like 1x. It's just the coefficient in front, minus 0.7. Okay, now you don't even have to multiply this because you're evaluating at 6. You have to go to your calculator and plug 6 in for t and see what the number is. Hopefully it matches one of the answers there. So I do a lot of SAT prep, and that's one of the things I have to work with on students is like, if your answer isn't there, the exam is rarely wrong. So it's probably, something that you did. And it's a tough sell sometimes for students to believe that. Okay, so you end up doing this and you get 0.52485. I don't like that though. I don't like that it doesn't have. Yeah, I don't like this. Let me just double check this here because it should be closer to, oh, it does say the nearest 10th. I guess that's okay then. I don't like when they're that far off, but that is the derivative. So we'll go with that. Okay, here we go. Find. All right. Find the derivative of the function. So again, like a bunch of the other problems we've done here, the derivative of the natural log of u is always 1 over u, whatever's inside the parentheses of the u, times u prime. So it's 1 over 4 plus x squared. And then the derivative of the inside function, it's the derivative of 4 is 0 plus 2x. So it ends up just being that 2x over 4 plus x squared, or x squared plus 4. And just find the one that it matches up with.
Mm.
Okay, 11, 12, 13, 14, 16. All right, go into a different email now. All right, put that in there. Okay, 31. Okay, find the derivative of the function. So log is a lot like a natural log. The derivative is always 1 over u, but then and times u prime, but it has this added little piece where you have to take the natural log of the base. And the base in this case is 10. It's not, when it's not written, it's log base 10. I think we joked, or I joked with you about the fact that like log base 10 logarithms, like that's how you know how old an engineer is you tell them it's a log problem and you see what they write on the board, whether it's
Right.
log or ln, and you're like, okay, you know, you're 70 plus, and anyway. Yeah, so in this problem, it's 1 over 7x minus 8 times the natural log of 10. Okay. And that, you know, if you just do that, that gets you down to either C or D as your, or I'm sorry, A or C as your possibilities, because they're the ones that match that. And then you have to take the derivative of the inside part. The derivative is 7x minus 8. It's 7 plus 0. The derivative of minus 8 is 0. So just the 7 on the top. And that's your answer there. All right, identify the open intervals where the function is changing as requested, increasing. So it wants to know where it's going up and to the right, up and to the right. So you can see it's going up and to the right. Let me switch colors here. Let's go, we'll go with this shaded yellow. It's going up and to the right, all in here, and then all in here. Okay, so that's -3. And that's +3. So if on this left one here, it's minus infinity to -3. And then the next one here is 0 to 3. So we just want the interval that contains both of those. All right, let me just look ahead here. All right, I'm okay to keep going if you are.
Yep, I'm
Okay.
good.
Okay, let's do that then. So let me let's keep going here. So, okay, so this is next question here. Find all the critical numbers of the function. So critical numbers means to take the derivative and set it equal to 0. So your derivative here, 2x cubed, that's 6x squared plus 9x minus 36. And you set that equal to 0. Now your first type of factoring is a greatest common factor, which I'm bothered by something. Okay, I did this wrong. Okay, that should be a 6, not a 9.
Yeah.
Because so I was looking ahead, all the solutions are whole numbers. And if this number doesn't factor out perfectly, the solutions are not whole numbers. So gotta be careful. Okay, so we're trying to find two numbers that multiply to -6, but add up to +1, -3 and 2, or 3 and -2. So it's obviously the second pair, x plus 3, x minus 2 equals 0 times 6. You set the factors with x equal to 0. So x equals -3 and x equals 2. It doesn't ask you to do anything more than that. So you all right. Next question here. Find the open intervals where the function is changing as requested. We want to know where this thing is increasing. So I'm actually going to grab a graph of this to help us answer this question. I think it'll be there's obviously a way you can do it without a graph, but let me just snip this in and we can look at it together. Okay, so we want to know where it's increasing. So again, that's where it's going up and to the right. So it's always going to the right, but we want to know where it's going up. You can see in this first part here, let me switch to a highlighter. It's going up and to the right, all the way up to this point right here. Okay, and we just care about the x values, right? So we just know that it's from -infinity to 0 is where it's increasing. I guess I didn't grab that part, but that looks like it corresponds to C. All right, next question, 35. So they even graph it in the next one. So I mean, it's like some problems are like, oh, don't graph, but really the graph is just so useful. Helps you to see what you want to do. So relative extrema, those are mins and then maxes. So I always think about it in terms of like hiking. If you ever go out hiking, you're relatively higher up or lower up than somewhere else around you. So this point over here on the left, that's a max. That's sort of a peak. And this point at 2, that's a min. That's a valley. So we have a relative minimum of 1. So this is what it is, and the 2 is where it is. So it's
Oh,
1.
okay.
It's corresponding to 1 there when x is 2, and then it's hard to see under the download symbols there, but it's -1. That's -1 on the max, but where it is at x is -2. So this is your best choice for this type of problem. All right, suppose the function with the given graph is not f of x, but f prime of x. Okay, that's very important. They're telling you this is the graph of the derivative. Okay, so where that changes things is that these peaks and valleys are not important, even though you want them to be. Okay.
Okay.
So the only place that matters is where it crosses. So where it crosses is either a min or a max. Okay. And if you remember, we made some sign charts. So if it goes from plus to minus, the original graph looks like this, and that's a max. If it goes from minus to plus, the original graph looks like that, and it's a min. So in terms of this point right here at 2, it's going from being negative to being positive. So that, in this case, when it goes from negative to positive, is a min. So there's a relative minimum at 2. Minimum at 2. Find the x values of all points where the function has a relative extrema. So this right here is the graph of a quadratic. And we know because of this negative in front that it opens down. So we could use calculus and we could figure out where that is, but I'm just going to graph it because it tells you as much information as the actual calculus does by getting a graph of it. So I'm going to go to Desmos and use that. It's actually kind of interesting on Facebook. A lot of these teacher groups, they're really holding back from like using Desmos. They really want to stick to using the calculators, which I don't understand. But maybe a lot of them it's because they got 50 of them in their classroom, and they're like, yeah, what am I supposed to do with these things? It's like,
Yeah.
I don't know. What am I supposed to do with my CDs?
Exactly.
Right. I don't know. So it's an interesting question here, but you can see right there's the peak. And that's again, they're telling you where it is and what it is. All right, let's keep going here. 38. All right, P of x is minus x cubed. Okay, so on and so on. All right, to maximize profit. All right, so they're giving you a profit function, and the profit function is only good when x is greater than 3. So there's most likely a graph here where it does something like this. And we want to find that point right there at the top. Now you could take the derivative and set it equal to 0, but what you can also do is graph it. The graphing is sometimes a challenge because of the size of the numbers. So that was always the issue with the handheld calculators. Like you got to get the right window. It's not intuitive to use. We can actually do this one reasonably by hand here. So I'll just take a derivative and we'll set it equal to 0. So it's minus 3x squared plus 30x minus 48. And that's just power rule again. A lot of power rule in this course. You set that equal to 0. You can factor out a -3 from all of them. So x squared minus 10x plus 16 equals 0. This ends up being x minus 8, x minus 2 equal to 0. And so you set each of those equal to 0 and you get x equals 8 and x equals 2. And you might be thinking, well, where's the answer 2? Because that's one of the answers. It says though that x has to be greater than 3, greater than or equal to 3. So this one is out. It's considered extraneous. 8 is the only possibility. 800,000 there.
Okay.
Okay. Find the requested value of the second derivative of the function. So the second derivative means take a first derivative, then take a second derivative. Your first derivative is done using power rule, 4x cubed plus 6x squared minus 4. And then you just repeat. You take 12x squared plus 12x. This time you're evaluating at 3. So you're plugging 3 in for x. 12 times 3 squared plus 12 times 3. So 3 squared is 9. 9 times 12 is 108. 36. Looks like it's 144 for that one. And that, full disclosure, there's a lot of calculators for almost every problem on this test, like this practice test. So you can you can always check your work if that was the goal. You could say, okay, I gotta make sure I know that I'm right, and you could just say, what's the second derivative of this function, and move on. All right, so next question here, 40 here. Okay, find the largest open interval where the function is concave up. That's kind of interesting. Why does it say largest? That's interesting. So this concavity is second derivative. So you got to find your first derivative. First derivative is 12x squared minus 90x plus 150. And then second derivative is 24x minus 90. You set that equal to 0. And x is 90 over 24, which reduces to 45 over 12, which reduces to 15 over 4. So our answers are either the ones with positive 15 over 4. And so either B or C. Okay, so that's a critical point here, 15 over 4. And what you do is you test points back in the second derivative. And this is kind of an awkward one to, it's like, what do you even test? Well, you could test like 0, because 0 is less than that. 24 times 0 minus 90, testing it back in this line here, that ends up giving a negative number. So that's concave down. If you test, like, let's say you tested 100, because you really just have to test anything bigger than it. 24 times 100 minus 90 is positive. That's where it's concave up. We want to know where it's concave up. So we want the interval from 15 over 4 to infinity. Like that. All right, so let me go ahead and do this.